meteorology, satellites and amateur radio by our chief guest, Dr. K.J. Ramesh. Weather plays a vital role in everyone's life, and the provision of accurate information about the weather is indispensable. And the ability to rapidly dispense this information about the weather is done using the radio frequency spectrum. Today, if you are receiving accurate information about the weather, please thank the weather satellites.
नील एंड उनका टीम ने ऑर्गेनाइज कर रहा हो तो आना ही पड़ा और आई एम एक्सट्रीमली हैप्पी टू बी पार्ट ऑफ दिस. सो एज यू हैव हर्ड फ्रॉम जय जी बिफोर my talk, so there is radio frequency and shortwave it started with, and you have now moved to satellite based communications. So this is happening in an atmosphere and above atmosphere, and going to, he has talked about moon, communicating with moon and earth. So it is a whole space you are using for operating the ham based communications. With the changing technologies, you have all other alternate means of communication, and you have multiple means of communication rather. So next one please. So in this you have three kinds of satellites. One satellite observes the weather and observes clouds, that we call weather satellites. And other satellites, there are communication satellites where transponder, TV channels, Tata Sky and all these things are there. So third is the GPS, where your locations, maps, which Google Maps and other navigation support systems which are supported. So all the three have a lot of communication infrastructure and channels, and they have their own dedicated functions without any overlap, and the allocation of these frequencies guided by ITU and controlled and operated by WPC in India for all communications which Jai ji has mentioned. And next one. So what is space weather? So when you talk about communicating up to moon, means we are atmosphere, beyond atmosphere we are going in a planetary space. So that is called space. So space weather refers to variations in space environment between the sun and the earth, basically, because throughout the solar system, sun is the main energy source for the planetary activities. All planets and sub-planets, you call them satellites, and they are natural satellites, and our satellites launched by human beings are called artificial satellites, and they are all primarily driven by the solar storms, means energy emanated from the sun and its associated changes. So this can happen in different parts of the sun's surface, but only earth directed solar storms will affect our communication system, all modes of communication, multi-modes of communication, which Jaiji has explained a few minutes before. So understanding the solar storm phenomena and how space weather changes and affects these communication systems. Whole globe and millions of ham operators are connected with these communication technologies. So we should know and what conditions and at what circumstances for how much time these communications can get affected, your signal can become weak. So that is called space weather is responsible for those signal variations and how that space weather related services are built. We know weather and climate services. There is also space weather services, which I am talking more about products. Some of the examples I will show from the National Oceanic and Atmospheric Administration of the United States of America. So why does space weather matter to us? So I just briefly mentioned, we know forecasts about hurricanes, cyclones, severe weather, thunderstorms, etc. So that comes from Weather and Climate Services, and these complex events can have economic consequences also. You know, natural disasters have a lot of economic consequences. But the kind of communication which we are talking is an emergency communication system when nothing else exists, as pointed out by Jaiji. So this works, and this is the means of communication during the emergencies and during the fair times to exchange issues of mutual interest, and particularly on emergency response, public safety related aspects. This is highly crucial. So that's how we should give equal importance to the weather and climate predictions and the natural hazards as we talk about, because it affects our life. Similarly, sustaining these equipments and communication activities, so we should know how say space weather forecast and their durations of affecting our lifeline infrastructure support system like HAM needs to be given equal priority. Next one please. So it affects our communication systems because a lot of distribution companies are connected by some of these frequencies. So power distribution will get affected, aircraft communication system will get affected, and then our GPS, navigational systems, maps and other information, everything operated on GPS satellites and GPS equipments will also get affected apart from our ham radio communications. Next one please. So space weather impacts on climate. So all weather on Earth from the surface of the planet out into the space begins with the sun. That we know about it. And then terrestrial weather are influenced by small changes in Earth's solar cycle. So little bit of change in Earth's radiation received from the sun creates a lot of changes in weather and climate. At the same time, most important aspect of the sun is the brightness of the sun. So the energy in the form of photons, that is through light, that emanates from the sun is emitted in different wavelengths. So one is visible wavelength, which we talked about it, and there is a spectrum range for it. And then this output of the sun wavelength nearly constant and changes only 1% in 11-year cycle. So the visible part of the radiation doesn't change much. So which one changes much, we will see. Next is the ultraviolet wave radiation, and that wavelength works between 120 to 400 nanometers, and this variability is the source of solar cycle. So 11-year solar cycle is that changes in ultraviolet radiation emanating from the sun is the main source of variability. So here variability is 15%. So visible radiation changes 1%, whereas ultraviolet radiation changes 15%. So next one is the extreme ultraviolet radiation. So that changes from 30 to 300%. So the changes which are significant in higher in percentages have to be given consideration and have potential to disturb or attenuate or weaken the signals which we are talking to sustain the ham radio communications. So the total wavelength integrated energy, so there is a calculation 1366 watt per meter square, and 1% change in the total solar irradiance can affect the earth atmospheric changes. You can imagine 1% of 1336 can create so much of thunderstorms, cyclones and other things. So at the top of the atmosphere, change in radiation changes everything on the planet Earth. The other types of space weather that can impact the atmosphere, energetic particles penetrate into the atmosphere and change the chemical constituents. Apart from the signal attenuation, something called nitrogen oxide also gets concentration of that gets changed in our Earth atmosphere. So that has different ramifications, and I am not talking about it now. Next one please. So now coming to main important HF radio communication. Space weather impacts radio communication in number of ways. So frequencies at 1 to 30 megahertz range, known as high frequency, we talked about it a few minutes before. The changes in ionospheric density. Ionosphere is that part of the atmosphere from 80 kilometers above the Earth's surface to 600 kilometers above the Earth's surface. So where all electromagnetic atoms, all other particles which have charge interact with each other and affect the communications of different wavelengths. So these X-ray photons ionize the atmosphere and create an enhancement of the D layer of the ionosphere. There is different layers of ionosphere, particularly this D layer. Enhanced D layer acts both as a reflector of radio waves at some frequencies, very important. The effect of propagating signals is highly variable. Up to some levels, effects of space weather on propagation can be mitigated through engineering design solutions. Some solutions are there to boost the signals. Up to some extent it is possible. But if you know that, then only you can trigger those technological solutions. Space weather, sometimes problems in space weather can create total loss of communication due to attenuation and severe scintillation when the broadcast signal cross the ionosphere. When such unfavorable conditions are there, it could be of severe impact. Next one, please. So this is a space weather service operated by National Oceanic and Atmospheric Administration of the United States period. So you have all these important forecast outlooks available of different types from the space weather services, which will affect these communications in particular. Next one, please. So this is a simple important thing, how much radiation changes can happen that can come from this sunspot number. So you can know how on monthly basis predicted sunspot number, when it is going to be high, when it is going to be low on monthly basis. So on monthly basis, now this table I am showing up to February 2024. So beforehand you can have an idea of how much variation in the sunspot number. So that is directly proportional to the changes in energy coming from the sun towards the earth, and through our earth atmosphere and ionosphere we are using all these communication systems. Next one, please. So this is a one particular example of high frequency getting affected. During the day, if you remember, when sun is overhead, attenuation potential is high. So you can clearly see this is for yesterday's situation, daytime when the sun is over North India. So this is the sort of, there is a range, color range is there up to 20 megahertz, depending upon the dark green, 20 to 25 megahertz signal attenuation can happen. So this is the kind of information generated 5 days before on a weekly outlook basis to the people. So it is a global information. Apart from United States, UK, Australia and Japan operate these space weather services. We have not started these space weather services in India. So we are keen to start, and a lot of new scientific manpower got to be generated who are working not only with atmosphere, with astrophysics and planetary science, and the communications from the ISRO side also should join this effort, then only that becomes possible. Next one, please. So at the polar latitudes we discussed about it. When aurora forms, the signal attenuation is pretty high. Next one. So electric power community also, power transmission gets affected. So there is a metric for that also. Whenever that value is higher, you will have a transmission related issues between the power transmitting agencies, power grid managers, etc. etc. Next one. So amateur radio communication happens in different ways, on which already Jaiji has told very much about it. I was only to concentrate on those issues which affects the satellite communications sustainability and its availability for ham radio operators. Thank you very much.